Alright, so we continue this class. Here we have for C, okay, a raised to the power of minus 1 is equal to this, and we are to find a. So it's just important to note that a raised to the power of, or let me just say a is actually the same thing as a raised to the power of minus 1 or raised to the power of minus 1. That means if I take the inverse of a inverse, I will get my a. So that's just that's just all they want you to do here. So here we are going to take the inverse of this, and remember to take inverse, you first of all, that's going to be 1 all over the magnitude of that particular matrix, and then you now take the adjoint by interchanging the right diagonal. So here we are going to have 5, and here we have 2, and then you now take the negative of the left diagonal. So this one is going to be 1, and here will be 3. Okay, so and what is the magnitude of this? So that will be 1 all over 5 times 2 is 10 minus 3. You multiply this way, and that's going to give us 13. Okay, and then we'll now have 5, 3, 1, and then 2. Sorry, this is supposed to be minus 3. Okay, so here should be minus 3, and then here should be 2. Okay, and that is the value for your a. You may choose to bring this 13 into your bracket, so you are going to have 5 over 13, 1 over 13, minus 3 over 13, and then 2 over 13. So whether you stop here or here, your solution is the same. All right, then for number 1c, is that 1? For not CII, that's question 2 CII. All right, so here we are told that 7a inverse is equal to this, so we are to find a. Okay, there are many ways you can actually go through this. One may be to first of all get the inverse of this and then divide by 7, and then another may be to take this root. You know, if I have 7a all raised to the power of minus 1 is actually the same thing as my 7 raised to the power minus 1 then times a raised to the power minus 1. So if I take this approach, I will still get the same answer. Okay, so which is the same thing as 1 all over 7, which is actually what I said, dividing by 7, and then you now take the inverse of this. And we already, do we have the inverse of that? No. Okay, so let's take that inverse. So that will be multiplied by the inverse of this. Will take 1 all over the magnitude. The magnitude is minus 3 times minus 2, which is 6, minus 7, and that will give us minus 1 into the bracket of, we interchange these two, which is minus 2 minus 3, and then we add minus to this other one. Okay, and so from here you are going to have this times this is 1 all over, let this okay, let me still write it. So this is going to be minus 2 minus 7 minus 1 minus 3. Okay, so there are two things we can do here. We can let this come into the bracket and multiply, and when that happens, you are going to have minus 1 over 7, minus 1 over 7 multiplying this. All the minus will cancel out, so we have 2 over 7, and then here we have 7 over 7, which is 1, and then this one will give us minus times this will give us 1 over 7, and then this times this will give us 3 all over 7, and that is the solution for that one. And then we go to number III. All right, so there we are given similar thing. You have 5 raised to the power of 8 transpose all inverse, so you can as well do the same thing. This will give you 5 inverse multiplied by 8 transpose inverse. Okay, right, and A transpose inverse could just mean the inverse of A transpose, which you can actually write this way. Of course, 5 inverse is 1 over 5, and you can write this one like this. It can actually be the same thing as A inverse transpose, okay? And of course, that would help what you want to achieve, okay? So, and it's part of the hint that was given to you, so I think that makes it easier for you, all right? And so remember, they said that this is equal to minus 3 minus 1. That's this one now. Here you have 5, 2. Okay, so what should we do? Now, they decided to multiply through by 5. So remember, I can use implies that so that you know that this is an equation. So if you multiply through by 5, it will clear this one. So you just have A inverse transpose is equal to, this will now be 1 over, you're multiplying by 5, so it will be 5. So there will be 5 times this. Now, if 5 multiply, we can quickly do that. 5 times minus 3 is minus 15. 5 times 1 is minus 5. 5 times 5 is 25. And then 5 times 2 is 10. Okay? So from there, that was how they got that other step, which if you push a little bit further, then you can take the transpose of both sides, because A transpose transpose will give you back your A. So in other words, if I take this transpose this side, so it will still be transpose. All right? So therefore, I'm going to transpose this, and so I'm going to have A inverse alone is the transpose of this, which is minus 15, then minus 5 will come down, then 25 will come up, and I will have 10 here. And then finally, they now said we should complete this to now give us our A, which is just to take the inverse of this. And to take the inverse of this, we are going to have that A is going to be 1 all over the magnitude, which is also the what's the name again? All right, you know what we have always called the determinant. Okay, so that's what I'm thinking of. All right, so the determinant of this will be this times this is 1 minus 150, then minus this times this is minus 125. So minus minus is plus, and that is going to give you 25. Okay, so over 25 here into the bracket of, so here you now have, you will interchange this, so that will give you 10 and minus 15, and then while, this is minus 25, not 25. Minus 150 plus 125 will be minus 25. So now, if you now put minus on this, you will have 5 and minus 25. So that minus 21 over 25 will now come in here to multiply. So if you divide this, you're going to have minus 5 into 10 is 2. So you have 2 over 5. Here you will have 1, because this will be minus 25 all over this times this will give you positive 25 over 25, while this times this will give you minus 5 over 25, which is minus 1 over 5. And finally, this one will give you 15 over 25, which is 3 over 5 if you reduce it to the lowest term, and that is the value of matrix A. Okay, and that is all for the B part. Sorry, is that the B part there? No, that is the C part, which gave us I to IV. All right, so and that is the IV we just completed. Okay, and then what's the next thing? Let's look at the question again, if there is any other thing they said we should do there. All right. Okay, so if you go over to the next part of the question, okay, that's where is the other question? Okay. Okay, the one we just did now is I. All right, so there is IV. I didn't take note of that. Okay, so there is IV there, and that IV, where is it now? Let me find it. Yeah, IV is inverse of I plus 2A. Okay, let me see if it's in the next page. Okay, no, it's not there. That means it's still down here. Okay, no, it's not even here. Okay, let's see. Okay, yeah, it's here. All right, so now how do you handle that one? Okay, so what did they ask us to do is the first question. So they are saying that you've got this I here represents the identity matrix, and then it's added to 2A, where A is just one arbitrary matrix, and then everything is raised to power of -1, and is equal to this. So they are asking you to get the A that will behave that way. So what do we do? One of the things we can do is actually to take the inverse of both sides. That's take this inverse to this other side, all right, and see what that is going to give you. Okay, so if we do that, what will that do for us? Yeah, it will at least clear up the left hand side a little bit. Okay, and then allow us to now begin to compare both sides. All right, so let's try to see if we can do that. Okay, so to take the inverse of both sides, we are going to have that I plus 2A is now equal to this one coming over here will now become inverse. Okay, so and the inverse of this is going to be that's going to give us, of course, you have 1 over the magnitude, and the magnitude of this is going to be -5 minus 8, which is -13. And then in brackets here you will now have this will interchange to give you 5 and -1, while you will now attach minus on all of this, which will be -2 -4. Okay, and you can keep that there. And then what's the next thing you will do? So you will now try to now first of all interpret your left hand side. So what does it mean? First of all, remember I said that this means identity matrix, and since we are talking about a 2 by 2 matrix, so we can write it in this form, 1 0 0 1. Okay, then plus 2 times, remember we don't know our A, so let's just give it any arbitrary name. All right, you can see all of these things even in the hints. Okay, so which is, they called it A, B, C, D. All right, and that is equal to, make the other side to be one matrix, which is 5. That's bringing the 1 over -13, so that will be -5 over 13. This one will be 2 over 13 because minus will cancel. This one will be 4 over 13, and this one will be 1 over 13. Okay, so if I have achieved this now, all right, so what I need to do is open the bracket here, so which will give you 1 0 0 1, which will be plus, if you bring in 2 here, you have 2A, 2B, 2C, and 2D is equal to this for our time. Okay, so here we will have -5 over 13, and 2 over 13, and 4 over 13, and then 1 over 13. Okay, so what we will get eventually is that, of course, you know addition of matrices, you add component wise, so this will give you 1 plus 2A is this, then 0 plus 2B is 2B, 0 plus 2C is 2C, and then you now have 1 plus 2D. Okay, so everything is now equal to this right hand side, which is -5 over 13, 2 over 13, 4 over 13, and finally 1 over 13. Okay, so at this point you can now compare both sides to get the values of your a and b. So, and in comparing both sides, what do we mean? So you're comparing the corresponding entries, and that's actually where they asked you to finish. So I just did all this to show you how they got up to this point. So what you're supposed to do is, or to write in your material, is where I'm about to do now. So you compare both sides, which is going to give us this component here will be equal to this component. So I will have 1 plus 2a should be equal to minus 5 all over 13. And from there, I can solve to get my a. So, and that is going to be, take 1 to this side. So you have 2a alone is equal to minus 5 over 13 minus 1. And what's that going to give me? All right, that's minus 5 all over 13 minus 1 over 1. If you take LCM, you will have 13 here, minus 5, and then minus 13, which will give you minus 18 over 13, right? And that's equal to 2a. Okay, so from here we can now say I have 2a is equal to minus 18 over 13. Divide both sides by 2. I will get that a is equal to minus 9 over 13. Okay, so this is the value for my a. And then for b, I will also correspond this second term and this one. So if I correspond them, permit me to draw a line here. So I will have that 2b will be equal to 2 over 13. So just divide both sides by 2, and you will get that b, 2 will cancel 2 here. You just have 1 over 13 as the value for your b. And then for c, compare this side and this side. So you have 2c is equal to 4 over 13. Also divide both sides by 2. 2 will cancel 4 to give you 2 remaining here. So my c is 2 all over 13. I'm done with that. And then over here, I can try to finish my d here. And for d, you have 1 plus 2d is equal to 1 all over 13. So take your 1 to the other side. You have 2d alone is equal to 1 over 13 minus 1. Let me quickly do it here. 1 over 1, your LCM is 13. This will be 1 minus, this will give you 13. And 1 minus 13 is minus 12 over 13. And if you now divide both sides by 2, you will get that your d alone will be equal to 2 cancelling 12. Minus 12 will give you minus 6 all over 13. Okay, so and that has given us the complete solution of the 4 variables we are to find, which are a, b, c, and d here. Okay, so that completes the solution for our CIV. Okay, now so you can put that matrix, you can put those 4 entries in one matrix to now get your a. So our a is actually equal to the matrix a. Sorry, the entry a is minus 9 over 13. And then the entry b is 1 over 13. Entry c is 2 over 13. And entry d is minus 6 over 13. And you may choose to bring out that 1 over 13. And then you now have minus 9, 1, 2, minus 6. It's your choice. So you can leave it here or bring it to this point. Okay, so and that is all for that part. So we move over to our E. Okay, so but before E there should be D. Did I jump D? Okay, because this is C here. Okay, so it means I jumped the D part, or did I write it somewhere else? Permit me to check. Okay, there's no, there's no D here, so permit me to write it. Okay, so or let me just read it. So for our D, we are told that you are to consider this problem. And what is the problem? You are given 3x1 minus x2 plus 2x3 to be equal, everything there is equal to 5, and we are to okay, so let me read the question. The question now says, consider the problem of determining whether the following system is consistent or not. Okay, we want to check if that system is consistent. And now, what is the meaning of a system being consistent? That means the system has a solution. Okay, so when a system is consistent, then it has a solution. And then how are we going to do that? Okay, so one way is try to solve it and see if we are going to get a solution, right? So, and in doing that, we will know whether we are going to, we will be able to do that. All right, and then that was not the end of the question. They now say define appropriate vectors and restate the problem in terms of linear combination. Okay, that's the hint they decided to give. So they said we should restate the vectors, and this is what that means, to get the vectors that produce this system, and that's very easy to do. Okay, so the first vector is going to be, of course, you are just going to pick the coefficients of x1 as your first vector, the coefficient of x2 as your second vector, and the coefficient of x3 as your third vector. So this is going to be 3 and minus 6. They are going to be column vectors, and v2 will be equal to minus 1 and 3, and then v3 is going to be equal to, sorry, instead of calling this hint, you can actually call it solution. So you are already solving, and okay, you are writing it after where they wrote define appropriate vectors. Okay, so because that is the part they gave you to use in solving this problem. All right, so and the last one here will be 2 minus 7, although that wouldn't be the only last vector because the constant part is also part of it. So I can bring this way. So the constant part is I can call it vector b is equal to 1 and then 5. Okay, so now what are they asking us? So they are now saying what you can do to know whether this system is going to be consistent can actually be to check if our b is going to be a linear combination, a linear combination of v1, v2, v3, which is actually what this equation is doing. Because for you to check whether this b will be a linear combination, you will need to solve this equation in the process of doing that. But of course, they said we should consider the problem of determining. So we are not really told to determine. So we will just now tell them that yes, that for consistency, you can just write this, for consistency from the vectors we got, for consistency to exist, for consistency to exist from the vectors we got, the constant vector b must be a linear combination, of v1, a linear combination of the vectors v1, v2, v3, and the rest, okay, of v1, v2, and what? v3. So that is enough, which is, like I said, that's actually what gave rise to this equation. All right, so that's what gave rise to this equation, because in determining for linear combination, I will need to multiply this vector with something, multiply this, and equate it to this, which will finally bring me back to here. So this is all you need, to be able to determine whether this equation or the vectors are whether this equation, the system of equations are consistent. Okay, so finally we have the E part here for the question 2, the last part of question 2. Okay, so and they say determine H and K, the value for H and K, so that the solution set for the system, this is a system. What's a system of equations? Sorry, I've been using a system of equation is just a where you have a set of equations, more than one equation. Okay, so when you have more than one equation, you call it a system of equation. All right, so now they are asking us to determine the value of H and K that will make that system, the solution set of that system, to be empty. All right, so let's try to do that. And what are we going to do? So sorry about that. So what are we going to do? Look at it now. Here, for this system to for you to know the type of solution set that this is, and meanwhile there are 3 types of solution sets, majorly 3. One is what we call infinitely many solutions, and then you have what you call no solution, which is where you have the empty solution set, and then you now have what we call unique solution. Okay, so you would need to first of all reduce this system into what we call the echelon form. Okay, so it has to be in its echelon form for you to be able to determine that. Okay, so what do? You either reduce that echelon form in this state, or you can transform it into the matrix form. Any of the approaches is okay. So let me use the matrix form. The matrix form will just be to bring out the coefficients here, 1, 4, 2, and then the coefficient here is H, and then you will have the constant side, demarcate it with some dots. All right, so here you now have that this is the matrix. We call it the augmented matrix of this system. Okay, so from this augmented matrix we can try to reduce. So, and what do we want to achieve? We want to achieve that anything below this my line should be 0. Okay, so we do that using Gaussian elimination. All right, so what do? You are going to write an algorithm that will help you get 0 here. So, and to do that, you are going to replace row 2. So now I want my row 2 to become, how do I do that? Multiply row 1 by 4. If I multiply row 1 by 4, or let me do it this way. So since I'm replacing row 2, let me start with row 2. So row 2 minus 4 times row 1. How did I get that? If I multiply here by 4 and subtract this, I'm going to get 0. And I want to use it to replace this particular row 2. So, and that is going to give me what I want. So let's see that the only thing is that you are going to do it for the whole of the terms in that row 2. But your row 1 will remain the same because you are not changing it. So you have K here. And then your row 2 will now be, if I now do this, row 2, for this term, I have 4 minus 4 times my row 1, there is 1. That's going to give me 0. And then I'll do for the second one, H minus 4 times the entry here for row 1 is 2. And that's going to give me H minus 8. Okay, and then on this side, I will have 5 minus 4 times K. Okay, and that's what I will write here because I don't know my K. Okay, and I will close the bracket. So you can see that's what it means to do row reduction, which we call Gaussian elimination. There are other things like exchanging some rows depending on what you have. All right, so but for now we don't need to exchange any row. All right, so let's go ahead now. We have achieved what we wanted. We have made this to be 0. So what now are we going to do to know what our solution will look like? Now, like I said, the nature, when you have reduced to echelon form, that's now when you are able to determine whether your solution is infinitely many. And then how do you know infinitely many solution? Is that for infinitely many solution, you don't want here to be 0 and you don't want here to be 0. Okay, sorry, you want here to be 0, you just want what do you call it, a lesser number of equations to the number of variables. You know, here we have 2 variables, so if I eliminate this particular row and I just have this, then I'm going to have infinitely many solutions. Okay, so in other words, for infinitely many solution, let me write it, infinitely many, what will happen is that my h minus 8 must be 0, and at the same time my 5 minus k must also be 0. But you know that this is not what you're looking for. You're looking for 0 solution. And what is, sorry, no solution at all. And what is the other one, which is no solution now? Okay, what's the condition? The condition for no solution is that you should have an inconsistent equation. So like here now, assuming that my this left hand side becomes 0 and here is not 0, then I have an inconsistent solution, because it is not possible for here to be 0 and here will be a number. For instance, 0 cannot be equal to 2. Okay, so once you have an untrue equation, you now know you have what we call no solution. Okay, so in that case, for me to have no solution, h minus 8 should be 0, and you can see I'm using and, that means 2 of them must happen, and 5 minus 4k must not be 0. Okay, so when I have that, what it means is that, and this is what I want, no solution, meaning that the solution set will be empty. Okay, so I need to now solve this. So and for this to happen, my h should be equal to 8, and my, if I take this to the other side, remember that this thing is k. If I take this to the other side, I will have 5 is not equal to 4k, so which means that my k alone must not be equal to 5 all over 4. So I've gotten the 2 values that they are asking for, that is my h and my k. So for these 2 values, your system will be inconsistent. That's actually what we call it. That's no solution. Okay, so and that is that for question number 2. Remember where we started? That was a day before today, right? So we started from somewhere here. That's, yeah, question 2. This was the one we did earlier. Okay, no, we started module 2. Okay, and yes, yeah, module 2, and we did question 1 and then got into question 2. All right, and then from question 2 we finished up somewhere here. Okay, so this is the end for your question 2 in module 2, and so we are going to get over to question 3. All right, so hello, in continuation of these solutions that we started earlier. Okay, so we are going to questions 3. Recall that we ended the questions 2 from module 2. Okay, so this is question 3, and it says if we have an equation ax equal to b that is inconsistent for some x in R, and remember I said that an equation is inconsistent if it has no solution. All right, so what can you say about ax equal to 0? Now this equation is called a non-homogeneous equation. Okay, so this is a non-homogeneous equation. And why is it non-homogeneous? Because the constant part is not 0. So while this ax equal to 0 is the homogeneous part of this non-homogeneous. Okay, so and we know that there is a rule which you can actually call a theorem or a remark or whatever, that says that when the when a non-homogeneous equation is inconsistent, then the homogeneous part of that equation is going to have a non-trivial solution. All right, so and that is what they want us to state here. So the equation ax equal to 0 will have a non-trivial solution. And you know what it means to have a non-trivial solution? So non-trivial solution is another word for it is non-zero solution. Okay, so trivial means zero solution. Okay, so now what we are now saying is that for your ax equal to b, which is the non-homogeneous equation, to be inconsistent, then this guy is definitely going to have a non-trivial solution. Okay, so we move away from that. Of course, you can see that this is very easy, to handle. Because all right, so we go over to question B then. All right, B says, do these two planes intersect? If yes, then describe their intersection. Okay, so if we can try to see if we can write these two linear equations here as a linear combination of some vectors, and then such that those vectors will have certain properties. That's what is going to help us know whether they intersect or not. Okay, so let's try doing that. So first of all, we will try to solve or reduce this equation into the echelon form. Okay, so permit me to do that. And what is it going to be for me? So to reduce it, I think I've done one example like that, or an exercise like that. So I will try to eliminate x1 from this column, and to eliminate that, I'm going to write an algorithm. Okay, so let me put it this way. So let that algorithm be, of course, how do I do that? R2 minus, of course, if you multiply this by 2, it will give you the same coefficient like this, and so a subtraction will make this to become 0. All right, so this algorithm will be enough to eliminate this. And so what is it going to have? Recall that your first equation is going to remain the same because you did not change it. Okay, so I'm going to have the same 5x3 all equal to 0. Now the one I'm replacing is my R2. So of course I'm supposed to put this like this. R2 should become this. So this is my new R2, and I'm going to apply it across this system of equations. So let's go. So this R2 now minus 2 times this is going to be 0, so it will be eliminated. And then we come over here, this R2 now, that's x minus x2, then minus 2 times this, which is 8x. That's going to give me minus 9x2. And then we go to the last part. So under the last part here, you will have 8x3 minus 2 times minus 5 is going to be minus 10x3, and minus minus is plus, so that is going to give us 18 plus 18x3 equal to 0. Okay, so we have been able to try to reduce this. So what do? Of course, you can see, let me come up here because of space. All right, you can as well do this in your material. If there is no space, then of course at the time I finish, I'm going to show you the areas that you're going to write, what is important. But of course I need to show you how we got to that. All right, so here now I am going to have x1 plus 4x2, then minus 5x3 equal to 0. Now this is going to be what is left here, but you can see that there is a divisor here. All right, minus 9 can divide through, and minus 9 divide this will give us x2. Minus 9 divide this one will give us minus 2x3, and that is equal to 0. Was that 0? Sorry, we did not get 0 here. remember we didn't do for this the constant part, sorry about that. So here is supposed to be 9 minus 2 times 0, which is also 9. Sorry, so this is supposed to be 9, sorry about that. And then so here we are going to have of course you are dividing through by minus 9, so this one will now give us minus 1. Okay, so at this point it will be good for us to now make of course you can see that the only free variable we have here is x3. All right, so we can give x3 a name. So let our x3 be equal to t, or you can just leave it as x3 if you want. Okay, but then we have 2 pivots, so you can give it a name. All right, so what will happen is that your x2 from equation 2 is now going to be equal to, this is minus 1, and here is now minus 2t. So this minus 2t coming over will become positive, and then minus 1. All right, and then if you now substitute everything here, your x1 plus 4 times x2 is now 2t minus 1, and then minus 5, and your x3 is t, all equal to 0. So we make x1 the subject, and that's going to give us, this will be 8t minus 4 minus 5t equal to 0. So I'm going to get that x1 is equal to, this is going to give me, if I bring over 4 here, minus 4, it will become 4. Now 8t minus 5t will be 3t. If you move it over, it will now become minus 3t. Okay, so I've gotten the 3 values for x, and so I can now, yeah, that's your x1, x2, x3. So I can now write this in a matrix form. Okay, let me go up a little bit, or this way. Okay, so I can put this in a matrix form now, and that is going to give me something of this nature. So you are now going to have that your x1, x2, x3 is equal to, so my x1 now is 4 minus 3t, and my x2 is 2t. Of course, let's try to put all the t's behind. So this is going to be minus 1 plus 2t, and then here I will now have, that's 0 plus t, but let me just put it as t alone. Okay, so and then you will see what will happen. From here we can split this into 2 vectors, which are going to be, the first vector will be the constants without t. So you have 4 minus 1. Remember I told you this is 0 plus t, so 0 will be here, and that is plus, in this side now I'm going to have, so you just have minus 3t. So, and I can put only the coefficient here, then 2t I'll put the coefficient, and t I'll put the coefficient. So behind it I will now have t outside, and these are the values for your x1, x2, and x3. Okay, so now you can see that we've been able to express this system into a linear combination of some vectors now, and there are 2 vectors here, which is 4 minus 1 0, minus 3 2, and our x. Okay, so and so from there now we can now begin to come back to the question. Okay, so now we for the fact that we're able to express that as a linear combination of 2 vectors, then it means that there's going to be an intersection of the 2 planes. Okay, so coming down here, they now said okay, this is what I just did there. Actually, that's what they are showing us here. So if you do a row reduction, blah blah blah, they first reduce this into matrix form, and then that's how we got this. And so from there they now okay, reduced it into the row reduction form, and if you see when I reduce, that's exactly what I got here, all these numbers that you're seeing. Okay, And so they said complete this and show us the that the intersection is a line through a vector u in the direction of a vector v. So our vector u now is that one vector, the first one here. This is our vector u, while this is our vector v. So that's what they are expecting us to fill here. So we have 4 minus 1 0. So our vector u is 4 minus 1 and 0, and then our vector v is going to be minus 3 2 and 1. Okay, so we have vector v as minus 3 2 and then 1. Okay, so and that is the solution to this problem. So in writing this for your material, you don't need to solve all of these that I did here. Just fill only these two. That's all they required you to do. Okay, and so we move on to the next question. And the next one, being example C, says that we should fill in the missing entries. In other words, they're asking us to get the values for these entries that are represented with question marks here. Okay, assuming that the equation hold for all values of the variables. Okay, so what are they expecting us to do? Of course, it's a very simple thing to see. Okay, so first of all is to note that you can actually transform this equation, this set of matrices here to be of this form. So now let's go into this way. First of all, let's give names to these question marks. So let me call here A, B, C, D, E, F, then G, H, I. Okay, is multiplying x1, x2, x3, and that is equal to, so you are going to discover something that here can actually be transformed to look like this place, where I will bring out my x. Let me do it immediately. My x1, x2, x3. How did I do that? In doing this is very easy. Just pick out the coefficients here and make it a row. Make it is it going to be row now? Yes, make it a row matrix. So you know, during matrix multiplication, you pick row and multiply column. By the time you do it, you will get back what we are given here. So watch what I'm going to do. Here is going to be 2, not 2. The first component here will be x1. Remember, x1 is the first component and there is no x1 here. It means that the coefficient is 0. Your x2 is coefficient 2. Your x3 is minus 1. x1 here, the coefficient is 1. x2 here, 1. x1 here, minus 1. x1 here is 1. x2, no x2. x3, no x3. Alright? And so you have produced a set of matrices that look exactly like what you have here, and you are done. Therefore, you're just going to correspond the corresponding entries, and that is the values that you're looking for. In other words, our A, which is the first entry there, is 0. Our B is 2. Our C is minus 1. Our D is equal to 1. E is 1. Then F is minus 1. And then G is equal to 1. Our H is equal to 0. And our I is equal to 0. And that's exactly what you're asked to find. Okay, so they said we should find the values that will satisfy this. That's exactly what we have done, and that's for C. So we move over to the next. So in example 4, we are given that if there is a 4x4 matrix A, if a 4x4 matrix A cannot be row reduced to I4. I4 means, where is it? I4 there talks about identity matrix of order 4. Okay, and then it says what can you say about the columns of the matrix A? Okay, so these are part of the deductions that we get from the columns of a matrix that is reduced to its echelon form. And so what is that? So if you cannot reduce it to this particular form, you only deduce that it means that those columns are linearly dependent. Okay, so it implies that the columns, all right, so the columns of A, so it means that the columns of A are vectors that are linearly dependent. Okay, so are linearly dependent, and thus, of course, the implication, if they are linearly dependent, dependent, they cannot span. Okay, so you remember by the time you define span, but you don't necessarily have to put this part, but if you want, so you can put that, and therefore do not span R4. So what we mean by this is that we are saying that the columns of that particular matrix, after being reduced, they don't have the ability to produce the whole of R4 by linear combination. That's the meaning of spanning. Okay, so we move over to number 3E. Okay, so this one now, we are given two matrices, A equal to this and B equal to this. Find X so that AX will be equal to B. Alright, and they started giving us some hints here. Alright, what we expected to do first is that we should just find the inverse of A. Okay, so because look at what you are told here, that you are looking for the value of X such that AX will be equal to B. And for you to do that, you would need to take this A to this side, and so if that A goes to that side, you will have that X is equal to, now what you are going to get is that X is equal to A inverse B. That's actually how they got this. Alright, so now they are saying that all we need is just to get the inverse of A and then use it to multiply B, and that will give you the value of X. Now, but there is another way we can do that. We can just use row reduction, and that's exactly what they expect us to do. So you may adopt this method, row reduction of this, and then when you reduce, all you're looking for is how can I get one side, that's the part where there is A, to turn to identity matrix, and then the remaining part will now be your X. Okay, so let's try doing that. So we bring in A here, which is 1, 3, 8, 2, 4, 11, 1, 2, 11, 1, 2, 5. Then we have, okay, let's demarcate here. So we now have -3, we have 5, we have 1, 5, we have 3, 4. Okay, so you are going to have that this, okay, is the matrix, so, and is augmented. So we will try to reduce this matrix to echelon form. That's going to, not just echelon form, we are trying to make it to be like this. That means this part before this dotted line should become identity. That means the whole of this should turn to 1, 1, and then the whole of this should turn to 0, 0, and all of that. And then whatever you now have here will now be the value of your A inverse B, which is the value of X. Okay, and that's going to take a lot of work to do. I'm going to just take maybe the reduction of these two to 0 and maybe this one, and then I'll give you the final answer, because of course you cannot, all of it cannot be contained in this little space. Okay, so let's go. So from here, this is going to give me my row reduction is going to be, I will multiply R1 by 2 and subtract it from R2 to be able to get my new R2. So my R1 will remain, so I'll have something like this, and then -3, 5. So my R2, which is row 2, I'm now replacing it with R2 minus 2R1, And if I do that here, I'm going to get 0. If I do that here, I'm going to get minus 2. If I do that here, this will be minus 11 minus 16, which is minus 5. Okay, if I do that here, I'll have 1 plus 6, which is 7, because minus 2 times 3 will be plus 6. Then here I'll have 5 minus 10, which is minus 5. Okay, so to reduce this one, just do R3 minus R1. Remember that this is your pivot. Okay, so if we do that, here will turn to 0. This will become minus 1. This will become minus 3. Okay, this one will become, you are subtracting this, so this one will become 6, and this one will become minus 1. All right, so I have reduced these two to 0. I need to reduce, but before I reduce here, I need to change this to 1. Remember, I want to achieve all of this to be 1. So, and to get here to be 1, I need to divide this by minus 2. That's row 2 by minus 2. Alternatively, we can switch row 3 and row 2, since this one is giving me 1. Okay, and in switching it, we will automatically be multiplying this by minus 1. So see what we are going to have. 138 dot minus 35. Okay, so here we now have so this one will now come up 0, but remember I'm multiplying through by minus 1, so that here will become positive. So I'll have 1, then 3, then minus 6, then 1. Okay, so and then I'll bring this one down, but in bringing it down, I should also multiply, or let me leave it that way, minus 2 minus 5, then 7, then minus 5. So what do I want to do again? I want to now reduce this minus 2 to 0. Okay, and in doing that, I'm going to have something of this nature. Let me draw that again. Okay, so my 1 will remain. I will have this, I will have this. Okay, okay, so I'll have minus 3, I will have 5 here. All right. Okay, so equation 2 will also remain, because row 2 will also remain, because I'm not replacing it. This is minus 6 1, so I'm replacing only row 1. And how am I replacing it? The algorithm should be that the new row 3 should be, if I multiply row 2 by 2, I'll get 2, so the addition will give me 0. So I'm going to get row 3 plus 2 row 2. Okay, so and that here is already 0, so here will now turn to 0. Now row 3 here is minus 5 plus 2 times 3, which is 6, so here would give me automatically 1. Wow, that's beautiful. And then under this side, I will now have 7 plus 2 times this is minus 12, and that's going to give me minus 5. And then if I come here, minus 5 plus 2 times 1 is 2, that's going to give me minus 3. Okay, so this is very beautiful. So I've actually achieved my zeros in the lower part of the triangle. Of course, that's the lower triangle, that's what we call it. Now to get the upper triangle to be 0, that's this place, I will perform the same operation for these two and for this. Okay, so but then, like I said, there won't be time to do all of that here, so I'm going to give you what the final operation is going to be. So it's going to look like this. Let me use this: 1 0 0, then here you have 0 1 0, then here you have 0 0 1. So this is what they want you to achieve. And then on the other side, we have 10 minus 1, then we have 9 and 10, and then we have minus 5 and 3, minus 3. And this final answer here can give you an idea, because we already have something like that here, and you know that we're only going to replace row 2 and row 1 because that's where we are deleting. So that means we actually got our answer here already. Okay, so and this is a transformation and this is the final answer. So if you are writing, all you needed to do is you can also go these steps that I've gone and then just tell us that this will go to the final reduction will be this. And so your final answer for x is going to be that your x, which is equal to A inverse B, is equal to this other part that is attached to this identity matrix, and that is 10 minus 1, 9, 10, and then minus 5 minus 3, and that is our solution. Okay, so that is a solution for number 3E. Okay, and so, and if you want to know whether what we've done here is correct, just try to multiply your A by these elements that we got. You see, sorry, by this matrix that we got, you will see that you are going to get B. Remember that the first thing they gave us here is that A times X is equal to B. So you can multiply this A, which is this one, by this X that we got and see if you are going to get this B. You will definitely do that. Okay, so and that is the end for exercise 3. Exercise 3 of module 2.